Hey, what's up, Bloomfield? Welcome to this edition of Mr. Wood's Awesome Math class. Today, we're going to be getting prepped and ready for our Chapter 2 test. So let's get started, and here we go. So the very first type of problem we're looking at an evaluation of some form of function. Well, we know whatever is inside here, that just means x. So I'm taking f of 23. Well, that's my x, right? So I know that this tells me that x is equal to 23. So all we're really doing is just plugging in and evaluating. So we do this fourth root of negative 7 plus 23 divided by 423 plus 2. Right? So negative 7 plus 23 is going to be the fourth root of 16 over 25. And fourth root of 16 is 2. So this answer is just 2 over 25. And that's the evaluation for number 1. All right, so if I wanted to evaluate number 2, once again, all of this is going in place of x, right? Because that's like saying f of x. Well, when x is negative 2 plus x. So I'm putting in fourth root of negative 7. Instead of x, we're putting in plus negative 2 plus x. All right, so there we go. And then on the bottom would be negative 2 plus x. So it'd be negative 2 plus x plus 2. So this is just going to become negative 7 and a negative 2 makes fourth root of negative 9. And then this would become plus x all over x, and that is as far as we can go, and that's the answer for number 2. Okay, so for number 3, what we're doing is once again plugging this in. So I got x minus 7, and that's got to be the squared minus 5. Well, when I square this, we get what? X squared minus 14 plus 49. There's supposed to be an x there, minus 5. So this would just evaluate to x squared minus 14x then plus 44, and that's the answer for number 3. Okay, for number 5, this is our difference quotient thing, so we're really doing this as two different problems. The first part that we need to find out is what is f of x plus h. So if I plug that in, I have a negative 2, and then we have x plus h squared plus 1. And then we have to do what is f of x, right? So what is f of x? Well, when I f of x, I'm just plugging in x in place, so it's exactly the same thing. So I just get minus 2 x squared plus 1, right? That's f of x. Well, when I do this top part, I get minus 2. So this becomes what? X squared plus 2xh plus h squared, all plus 1. And we are then multiplying the 2 in, so I get minus 2x squared minus 4xh plus 2h squared, all plus 1. And we're subtracting negative 2x squared plus 1. And we can see what's going to cancel out. The x squared is going to be minus x squared, 1 minus 1. And so I'm going to have minus 4xh plus 2h squared all over h. Well, this is going to divide out the h. So it's just going to leave me with minus 4x plus 2h. And that is our answer. All right, for number 6, determine the average rate of change. Well, I know this is asking about slope. Well, once I know I'm thinking about slope, I got to do y2 minus y1 over x2 minus x1. Well, what is x2? This is telling me, this interval piece, interval is telling me that I have x1 is negative 2 and x2 is 3. We just got to find out what is y2 and what is y1. Well, y2 would be whatever that value is when x2. So I'm just going to plug in negative 2 times 3 squared plus 3 minus 3. So that would go away. So this would become minus 2 times 9, or negative 18 would be y2. y1 would be, what is it when x is 1? So I get negative 2 times negative 2 squared minus 2 minus 3, or this would give me negative 2 times 4, and then this would be minus 5. So this would say I got negative 8 minus 5, or negative 13. Well, when I do the slope, so when I actually perform the slope and do the average rate of change, then I'm going to do negative 18 minus negative 13. all divided by 3 minus a negative 2. So this is going to give me negative 5 over 5, and average rate of change would be negative 1. And that's the answer for 6. Remember here when we're thinking about domains, we're only thinking about what are the possible restrictions, right? So what things restrict the domain? What things cause restrictions? Because without restrictions, it's just always negative infinity to positive infinity. But we know that there are things that can't happen, right? So I know that I can't divide by 0. So we know that I can't say something divide by 0. That gives me an error. And I also know that I can't have a negative inside a square root. I can't have a negative inside a fourth root. So either one of those would also give me an error. So unless I have a denominator or a radical, I really don't care. So the only part on this that's going to affect the domain is going to be the denominator here, right? So that's going to be the only piece that's going to, so when is 2x plus 1, when is that going to equal 0? Well, I move the 1 over, so subtract the 1, and I get 2x equals negative 1, and divide by 2. So we know that x here cannot equal negative 1/2. It can equal everything else except for negative 1/2. So if I think about a number line, here's 0, here's our negative 1/2. Well, it can't be this. It can be anything on either side. So how do I include that? I get values on both sides. So how do I say that? Well, I can say that it can go from negative infinity all the way up to negative 1/2. And we can go from negative 1/2 up to infinity. So that would be the domain for this function. All right, for number 8, we have the radical. So if I have a radical, we know that what's inside here, negative x minus 3, we know that it can't be negative. So in a way that we say that math is it has to be bigger than 0. So whatever this value is, so whatever negative x minus 3 is, it has to be bigger than 0, or else we get an error. So here if I move the 3 over, right, and I get negative x greater than 3, and divide by the negative 1. Now, don't forget, when you divide by negative 1, the sign must change. When you divide by negative 1, the sign must change. So here I get x has to be less than negative 3. So x has to be less than negative 3. So what does that mean? So it's here at negative 3, and it can be equal, right? So it could be equal to negative 3, but it has to be smaller than negative 3. So how do I write that? Well, that would be from negative infinity all the way up to negative 3 and includes negative 3. So that would be the domain for number 8. So for number 9, we're thinking, well, I got to factor this. Anytime I see an x squared, I know I should think, well, can I factor this? Well, this factors to x minus 5 and x plus 4. Well, I have a denominator. So the denominator we know can't equal 0. So therefore, I know that x minus 5 cannot equal 0, or x plus 4 cannot equal 0. So therefore, x cannot equal 5, and x cannot equal negative 4. So if I think about that on a number line, here is 0. Down here is negative 4 somewhere, and over here is positive 5. So I know I can't have those values, but I can have values over here on this left side of negative 4. I can have values between negative 4 and 5, and I can have values greater than 5. So if I think about the domain, I know that it has to go from negative infinity all the way up to negative 4. And then we have to pick up from negative 4 to 5, and then from 5 to infinity. So that would be the domain in interval notation. Okay, for 10, once again, all I care about is what is in the denominator. Don't care about the numerator. The denominator is the only thing that affects the domain in this case. It will affect other things later, but as far as the domain, this is the only thing that will cause a restriction. So let's see if I can factor that out. All right, so let's try to factor that. We get a 2x and I get an x. I know I get a 3 and a 1. right? And this would give me 6. This would give me 1. How do I get the negative 5? This would have to be negative. This had to be positive. So this would have to be negative. That had to be positive. So therefore, 2x plus 1 cannot equal 0, or x minus 3 cannot equal 0. So here, if I subtract the 1 over, I get 2x negative 1, and x cannot equal negative 1/2, and x cannot equal 3. So once again, thinking about it on the number line scenario, here is negative 1/2, here is 3. I know it can't be negative 1/2, it can't be 3, but I can get values on each piece, right? So I can get values over here less than negative 1/2, I can get values between 1/2 and 3, and get, so I know this is going to be from negative infinity to negative 1/2. This is going to be from negative 1/2 to 3, and this is going to be from 3 to infinity. All right, so here for number 11, we're actually trying to be able to graph this out, right? So the very first thing I need to do is, and it says on what intervals is it increasing and what intervals is it decreasing. So I'm looking for, is there increasing? We know that would be a positive slope, right? So any areas that have positive slope, decreasing, any areas that have a negative slope. So I'm actually going to graph it based off the transformation. So I know if I look at the parent function x cubed, so that would be here at 1 it's at 1, at 2 it's at 8, at 1 it's negative 1 it's at 1, and at negative 2 it's at negative 8. So that would be my parent function, and it would look like this, right? So, and I'm just going to use the 1 point here, negative 2, negative 8. And let's go through the transformations. So the very first thing, we know that this is going to move it 2 to the right, right? So I know I'm going to come over to 2. So if I move this 2 to the right, that's going to make that, instead of, it's supposed to be positive 2, I'm going to make that a positive 4. So moving it 2 to the right. Then it's going to multiply the y by 2, right? So the very next thing, it's going to multiply the y by 2. So instead of being negative, instead of being a positive 8, it's going to be a positive 16. Then it's going to flip it upside down. So it's going to multiply, make this a negative. And then it's going to move it 2 more up. So it would be 4, and moving it 2 up would make it at negative 14. So that point at 4, it'd be way down here at negative 14. So this point that was right there is now way down here. Right? If I go through that same process on each point, let's see, very first thing, this point that was at 1, 1, we're going to move it 2 to the right. So it was at 1, 1. We're going to move it 2 to the right, so that would become at 3. We're going to multiply the y by negative 2. So instead of being 1, it becomes negative 2. And then we're going to move it 2 up. So then I'm going to move it 2 up. So this point that was right there is now right 3, 0, right? So that would be all of the transformations for that point. Let's look at the next set. So the next set, the next point that was at 0, 0, we're going to move it 2 to the right, so that would make it over to 2. We're going to multiply the y by negative 2, so it still stays at 0. And then we're going to add 2 to it, so I'm going to make it at 2. So this point that was there is now at 2 and at 2. All right, the point that was, so that would be that. Now if I take the next point here, that was at negative 1, negative 1, and we're going to move it 2 to the right. So instead of being, so to make it at 1, we're going to multiply the y by negative 2, so that would make it to 2, and then we're going to add 2, so this would become 1, 4. So it'd be here at 1 and 4. And then the last point that was here was at negative 2, negative 8. We're going to move it 2 to the right, so that becomes 0. Multiply this by negative 2, so it becomes positive 16. And move it 2 up, so it becomes 0 and 18. And so 0 and 18, so 18 would be somewhere way up here. So my graph now looks like, and that's a graph. Well, let's see. Where kind of slope is that? The whole way is a negative slope no matter what I look at that. So it is decreasing from negative infinity to positive infinity. Looking at all of my x values, no matter what I go, this is always negative slope. The whole time is negative slope. So there we go. There's that problem. All right, so if I wanted to be able to graph this, let's go ahead and put it in vertex form. And so this would become x squared minus 6x. Move the 6 over, make it negative 6. So I'm going to fill the gap. I'm doing a b over 2 squared, right? So this would become negative 6 divided by 2, negative 3 squared would become 9. So therefore I got to add 9 to the other side. So this is going to become x plus 3 squared equals 3, and then this becomes x plus 3 squared minus 3. So that's our vertex form. We know our vertex then occurs at negative 3, negative 3. So my vertex occurs at negative 3, negative 3 right there. We know that it's going to go up. We know that our y-intercept is at 6. All right. I know that, so if I go over 3, I get to 6. So if I go over 1, 2, 3, I get to 6. So at 6 it'd be at 6 as well. And so my parabola is going to look something like that. And we're basically done with a quick sketch of that graph. All right, so for here, let's go ahead and maybe graph the parent function. And we know the square root of x. The square root of x at 0 at 0. At 1, it's at 1. At 4, it's at 2. And at 9, it's at 3. So there's my parent function. That looks like that. The square root of x. So I know then it's going to do what? We know that this is going to move it 3 to the left. So I'm going to take this point, move it over 3, 1, 2, 3, and then move it down 2. So that point goes to there. This point that was at 1, 1. So at 1, 1, I'm going to move it over 3, 1, 2, 3, down 2, so it goes to there. This point that was here, move it over 3, 1, 2, 3, so it goes to 1, move it down 2, so it comes to here. And then this point that was at 9 and 3, we're going to move it over 3, 1, 2, 3 to 6, move it down 2 to, oops, supposed to be at 1. And so my graph looks like that. So this is going to move everything to the right, right 3, to the left 3, and then down 2. So this is going to go left, right? And then we're going to go down. So just move every single point off of our standard, move it to the left 3, and then down 2. So when you're given a quadratic function, saying maximum value of the function, and we have an x squared, what is it really looking for? It's just looking for what is the vertex. What is the maximum value of that function? So what is the y value of the vertex is all it's looking for. So if I put this in the right order, negative x squared minus x and plus 1, I can then do one of two things. We could either plug in solve. Let's go ahead and complete the square. So I'm going to move the minus x and make this minus x squared plus x. Move the 1 over. And so this would become, so if I take that and divide by 2, so that would become 1/2 squared would become 1/4. And then over here would become minus 1/4. So then I have negative. This would become x plus 1/2 squared. And this would over here would become, so this would become a negative 4 over 4 minus 1/4, or negative 5 over 4. And so my vertex is going to be negative x plus 1/2 squared plus 5/4. So my vertex is what? Negative 1/2, and it occurs at 5/4. So what is the maximum value of the function? Is the y value of my vertex. So the answer here is just 5/4. All right, so for this function, it's just saying what is f of g of a. So this means I'm putting a into g. So the very first thing I got to do is find out what is g of a. Well, g of a is just, instead of saying 3x minus 2, it's just 3a minus 2. And if I want to say, well, what is f of g of a? So I'm putting that in place of 1 minus x squared. So I'm putting that in place of x. So I'm going to have 1 minus 3a minus 2 squared. So I'd have 1 minus. And then this would become 9a squared. So 6 would become minus 12a plus 4. And so I'm doing 1 minus that. So the answer is going to become, I'm going to put it in right terms, so negative 9a squared plus 12a and minus 3. And so that is the evaluation of, okay, for 18, we're first got to figure out what is f of 3. That just means I'm putting 3 in place of x. So I'm doing 1 minus 3 squared. So 1 minus 9 would become, this would become a negative 8. So f of 3 is negative 8. Well, then we also got to figure out, well, what is f of g of negative 5? Well, I got to first figure out what is g of negative 5. This would say, well, I got to say, this would say 3 times negative 5 minus 2, or negative 15 minus 2 is negative 17. So I'm putting negative 17 in place of f. So f of g of 5 would become, all right, so now I know that f of g of negative 5 is negative 288, and we said that f of 3, and we said f of 3 was equal to negative 8, and so I'm doing negative 8 minus a negative 288, and so this answer is just, if you can do this kind of composition, you pretty much can do any type of composition. So this is saying what is f of g of f. So what is f of g? So I can say it like this. What is f of g of f of x? So I got to put f into g and then that answer into f. So that's what that would, we would put f into g and then whatever that answer is into f is what that means. So the very first thing, so if I have 1 plus x squared and g of x equals square root of x minus 1, I got to put f into g. So let's do that. Let's put f into g. So I have 1 plus x squared, so square root, minus 1, which would just give me square root of x squared, which would just give me x. So f of g of x, or written this way, f of g of x, or g of f of x is just x. So now I got to find, well, this is just saying what is f of x, right? So I'm putting x into f of x. So the answer is just 1 plus x squared. And that was my answer. All right, f of g of 10. This is saying, first off, I'm putting what is the value of 10 into the expression. So this would say, well, 10 minus 1, which is the square root of 9, which is 3. And so I want to put that 3 into my f expression. So 1 plus 3 squared, or 1 plus 9, this is equal to 10. And so